This is your friendly neighborhood physics teacher here, and we're going to talk about kinetic energy. I guess I should type that out, shouldn't I? Just kind of sitting there like blank. Oh, what are we talking about? What's this video over? It's over kinetic energy. So a nice little review over kinetic energy. There's already videos over work and video over potential energy, so it has the elastic and gravitation. This is over kinetic energy. So our kinetic energy equation is 1/2 mv squared. This equation is on our formula chart, so we don't need to memorize it. But what we do need to know is the relationship of all the different variables in this equation. So as mass increases, our kinetic energy increases. That is called a direct relationship. And the opposite holds true. If your mass decreases, your kinetic energy would also decrease. Whatever that object does, they do the exact same thing. So it goes up, it goes up, goes down, goes down. So that's a direct relationship. For our velocity, we'll rewrite it here. So with kinetic energy, if we're looking at our velocity, so if our velocity increases, our kinetic energy is going to also increase, but it's going to increase exponentially. It's because of this sucker right there. So think about it. So if we have, let's say if we increase our kinetic energy, so we'll call this kinetic energy 1, we'll call this kinetic energy 2. So let's say we're increasing our velocity by 2. So the first run we did velocity just normal. Now we're speeding it up. We're increasing our velocity. So our kinetic equation, this 1/2, or this squared, would have to go to both the 2 and the v. So 2 squared is 4v squared. The big difference is this 4 right here. So we can pull that 4 out. So we have 1/2, 4, 1/2 mv squared. This and this are the same. So it's kind of like saying that your second kinetic energy is 4 times as much as your first kinetic energy. So if you double, so what that is saying is if you double your velocity, your kinetic energy is going to quadruple. And you could do the exact same thing for, like, saying if you triple your velocity, it's going to make your kinetic energy go up by 9. And so on and so forth. You could just keep going and going and going. As you can see, it's increasing. So this isn't just increasing by 1s. This is increasing exponentially. So that's what I mean by exponentially. That this is still a direct relationship. So it's still a direct relationship. Direct relationship. But because of this little squared right there, that little guy right there, it becomes a direct, put the square in the wrong spot, direct squared relationship. It becomes a direct squared relationship. So still a direct relationship. It's just because of that squared, it becomes a direct squared relationship. Take it a step further, we didn't necessarily talk about this in class, but we can talk about it now. So let's say we want to look at mass and velocity. If we increase the mass, and that's saying like, so when we like increase, that means the velocity stayed the same, and here that means our mass stayed the same. So now somehow our kinetic energy is staying the same. So think about it more as a lab, saying, okay, so you figured out the kinetic energy of a ball falling to the ground. I've given you a bigger ball. So we've added mass. And I want you to figure out what velocity it would need to happen so the kinetic energies are the same. So if your mass increases, your velocity is going to end up decreasing. Your velocity is going to end up decreasing. But again, we have to take that squared in consideration. So again, let's kind of do something like we did here. So this will make, again, our K1, because that's kind of not changing. But if we're looking at our K2, we have 1/2 2m v squared. Actually, hold on, before we do that, because we're not looking at our kinetic energy though, right? Our kinetic energy is not changing. We're looking at our velocity, so I was about to mess up. So let's solve for velocity real quick. So we want v by itself. So we're going to multiply both sides by 2 to make that cancel out. So we get 2k equals mv squared. We're going to divide by mass by both sides. So we get km equals v squared. And then we got to do the square root. So square root of k over m. So there we go. So that's our v. So we're going to make this v1. Now, if we're looking for v2, now remember the difference of v2 is we're going to double our mass. We're going to double our mass. So the difference, so if we kind of pull that out, because we want this to stay the same. I know y'all are just scratching to be like, oh, we can cancel out the 2's. Hold on. What we're trying to do is compare the difference between our v2 and v1. So we want this part to stay the same. So we can pull out the square root of 1/2. So it'd be 2km. So all that's saying is that the square root of 1/2 is that multiply that by our v1 gives us our v2. So that becomes a inverse. The reason it's inverse because we multiplied by 2 and we got 1/2. So that's, 2, the inverse of 2 is 1/2. So it's an inverse relationship. But since that square root there, it's an inverse square root relationship. It's an inverse square root relationship. So those are all the relationships we can pull out of the equation. I guess just a reminder, K does equal our kinetic energy. And that is measured in joules. M equals mass, and that's measured in kilograms. And V is velocity. and that is measured in meters per second. I guess I should have done that first. But just a quick reminder. So that's dealing with kinetic energy. Remember, kinetic means motion. So you have kinetic energy at any point in time an object is moving. If an object's moving, you have kinetic energy. Hands down. Yeah. So that's about it for kinetic energy. Hope that helps kind of go back over what kinetic energy is. If you have any questions, please let me know. Have a wonderful day. Bye.